Click the bell icon to get latest videos from Ekeeda.
Well friends, in the previous topic we have discussed about the numerical based on the decay constant, problem number 7, and now here we are going to talk about the problem number 8. So now let us understand what is the question which is given to us, and let us see how we can determine the value which has been asked for in this question. So friends, this is the question which has been asked, that is the half-life of chlorine 34 is 1.53 second. How long does it take for 99.9% of the sample of chlorine 34 to decay? So here we have to understand this question, because this question consists of various other datas. And what are those? Let me find it out here. Here basically the half-life of chlorine which has been given as 1.53, so I could write that is the given data for T half, that is the half-life is given as 1.53 seconds, and they are asking for how long does it will take. That means what is the time it requires for 99.9% of the sample to get decayed. So here basically the factor which has been present over here is percentage. So that means if 99.9% is being decayed, so what amount is left? So for that we can say that is the initial number of nuclei that has been present. Suppose that is N naught is suppose 100%, out of which 99.9% has undergone through decay. That means what is left, the N which is left after a interval of time, that is after T, is 100 minus 99.9, which is found to be 0.1%. So here basically we have various values, that is T half, N naught, N, as well as we have to find out the value of T. But we cannot find the value of T unless we have the decay constant value. But we can calculate the decay constant value with the help of this T half, and for that we have a formula. T half is equals to 0.693 the whole divided by lambda, that is decay constant. And since we have to calculate the decay constant, so therefore what we can do is I can equate this equation as lambda is equals to 0.693 divided by T half. So here the T half which has been given as 1.53 second, and here is the value of 0.693. That means the value of the decay constant will be in second inverse. So let us see what is the answer we could get if we divide 0.693 with 1.53. So here we'll get a value of 0.453 second inverse for the decay constant, that is lambda. And once we have got this value of decay constant, we can easily calculate the value of time which is required to convert from a particular NO to N. So let us find out what is the time that has been required with the help of the formula for the decay constant. We have the formula, that is lambda is equals to 2.303 divided by T log to the base 10 of N0 divided by N. So here basically since we have to find out the time that has been required, so therefore I could equate this as T is equals to 2.303 divided by lambda log to the base 10 of N0 or N naught divided by N. So let us fulfill the values, or let us substitute the values over here. So therefore we could get that is 2.303 divided by lambda, that is the decay constant which has the value, that is what we have got. So now let us substitute the values of the lambda over here, that is we have got as 0.453 second inverse log to the base 10 of N0, which we have assumed to be 100 divided by N. In this case it is found to be, that is 0.1. So let's see after calculation what is the value we could get, and the value of time, that is what we will get over here, that is the magnitude, it should be in seconds. The reason behind that is because here the decay constant what is we have got, that has a unit of second inverse. That means the time will have a unit in seconds. So let's see what is the value we could get over here. So we have got the value of time here as 15.25 seconds. So this is the answer, and this is how basically we can calculate this numerical. And thank you friends for watching this video. I hope you have understood this numerical very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.